I need to add myself one more thing to my to-do list. All right. Why y'all having a totally different discussion? We already take notes. All right. The next thing on our list is finding the complement, and I guess that's where the bell rang when we're just starting to discuss it. So, complements happen when you have a universal set. So, universal set is narrowing everything down to the particular group you're talking about. It might be, in this case, what is our universal set in this problem? Integers, right? Okay, but my universal set may not have anything to do with numbers at all. My universal set may be the set of all high school students in Deweyville. Okay, huh? Millions of high school students in Deweyville, right? Okay, so sets don't necessarily have to be numbers, but since you are getting math credit, you get a lot of sets that are numbers. So tell me, what numbers am I talking about? What do I mean when I say integers? Okay, which one? Is it all numbers and their opposites? Oh, whole numbers. Okay, whole numbers and their opposites. If you wanted to kind of get a visual, can we actually use the roster method for showing the integers? Really?
Ninth grade needs to be released to go take pictures.
I could have swore they went from like 12th grade now.
Today or
every year before this?
Well, new principle, new way of doing things. All right, so back to this. Can I use the roster method to list the integers?
No, that's a real one. It goes to infinity.
It goes to infinity. Actually, it goes to both infinities, to negative infinity and positive infinity. It's impossible to list them all. However, sometimes we use this symbol to indicate that a list keeps going on and on. Why would I put it first instead of last? Because we're doing the negative numbers. Now, when you're trying to give yourself a list, you just want enough numbers to show you what you're talking about, to establish the pattern. So how low would you go if you were going to list some negatives and 0 and some positives? -3 sounds good? Okay, that's not excessive. To be correct, you need a comma separating your 3 dots from your first element that you show. Because the 3 dots represents other elements. Elements are always separated by commas. Then I would keep going with what? Mm-hmm. Yep. 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 2, 3. Just keep it balanced, right? Because we go on forever. If you saw this, would you feel like you pretty much had a good idea of what we're talking about? Okay. So last year's notes, we didn't go all the way to the 3's. Do you think going from -2 to +2 would be maybe enough? Maybe. I think if I just used -1, +1, maybe I would be wondering what else might happen. I don't know. So, anyways, not technically the roster method, but it is still showing it in set notation. Got a question? Okay. So, now we know what the universal set is. They narrow it down. What is it called when you take a universal set and you narrow it down to just part of that set? What's that called? A subset. So they've given us, oh, you know what I should also put here? I should put the universal set is this, so I can label it. So they give me a set called S. And this time, they told me that the elements, we're going to refer to each element as the variable P. What does this say? What's it start off? Okay, S equals, or S is the set of all P's such that P is an element of the universal set. So, real quick, tell me something that will not be on my S list. Well, just with this information, what's something that I cannot use for S? So any decimal would be out of the question, wouldn't it? Okay. Now, continuing, we narrow it down further so that P is greater than or equal to 0. So how would you try to represent this set? Could I use the roster method for this subset? The fake roster method? Okay, because I can't list them all, it's an infinite set. But I can represent it in set braces, correct? So, what would you start with?
0.
What else would you use?
1.
Okay. What else? Think you got enough to establish what's going on here? Then what would I write? Ooh, before the dot. Make sure you use a comma to separate the previous element from your dot, from your ellipsis. Okay? Now, what does this little symbol mean? How would I read this? Okay, I would say S prime. What does it mean?
All the numbers that aren't in the subset that are in the universal set.
Well done. Okay, so our subset was S. It didn't include everything in the universal set, did it? There's some stuff that didn't get included in my subset, and that would be my complement of set S. Okay? So complement is the stuff that wasn't included in a subset. So if I wanted to, well, first of all, what do you think of this description? S prime, what variable they using this time?
Q.
Okay, the set of all Q's such that Q, okay, so it's one of the integers, and Q is not an element of S. That's a good way to show it, right? Okay. If I wanted to kind of show what numbers I'm talking about with a curly brace, can I list everything in S prime? Start with the dot. Why? It goes to negative infinity, doesn't it? Good enough? -3. What else? -2. Anything else? -1. Anything else? So, did I need the comma? No. I think I put the comma out of habit, but I'm not separating from any more elements, am I? So close that puppy up. So, the next question says, what are some numbers that could be found in S prime? So, Slade, tell me something that could be in S prime, but not one of the ones we see, because we already got 3 of them now. Give me another number from S prime. 4?
Wait, you say S prime?
S prime.
-4.
How about -4? That's a good one. Okay. Let's see. Campbell, give me another number that could be found in S prime. -6. Okay. Somebody give me something really creative that could be found in S prime.
-5 billion.
-5 billion. Okay. Yep, billion.
I ain't writing all that.
Well, you could pick another one.
You have to be part of your name.
I'll write it.
-7. That would also be another number. All right. Now, Next vocabulary word. Now I'm highlighting it. Equal sets. We played with this a little bit on the first page. Two sets are equal if they contain blank the same blank.
Exactly the same element.
Very good. Exactly the same elements. If that's the case, the sets are equal. All right? Now, let's look at two sets that I have defined here. Set F. What method did I use to type up set F? The roster method. I list them all. 1, 2, 3, 4, 6, 12. If I wasn't looking at this, could you give a name to that set? Could you give a verbal description? What do those numbers all have in common?
The factors of 12.
Factors of 12? Let's look at how I define set G. All right, how do I read this? G is
A set of all x's, such as x is an element of whole numbers, and x is a factor of 12.
okay. Why do you think maybe the whole number part was there? Because you just said they were factors of 12. Do you think saying they're whole numbers is excessive, or do you think it's needed?
I think it's needed.
I mean,
Are there any factors of 12 that are not whole numbers?
0.5.
0.5. 0.5 times 24 equals 12. Ooh. Yeah. So there are factors. Generally, way back in 5th grade, if your teacher said, find the factors of 12, she probably didn't stand there and say, find the whole number of factors of 12. We mostly assume when you factor a number that you're only looking for the whole numbers that go into it. But actually, the decimals can go into it, fractions can go into stuff. So this is a little more specific.
Good morning, Pirates. Today is Wednesday, September the 3rd. Please stand for the pledges and the moment of silence. First, the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Now the Texas Pledge. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible. Please remain standing for a moment of silence. Thank you, students. You may be seated.
Moments are getting longer.
Students, please remember that all outside doors on campus must remain closed and locked at all times. For your safety, never prop a door open or open a door from anyone from the outside. All visitors must check in through the front office. Let's remember our daily policy and procedure reminders. You must be in dress code, and part of your dress code is wearing an ID daily. We are already having too many students having to report to the office first period to get an ID. We're going to start handing out detentions and leveled and progressive consequences for not having your ID. Please remember, no outside food or drinks are allowed in the building, or energy drinks, no DoorDash. Also, no device that is gaming devices, earbuds, headphones, personal devices, laptops, tablets of any kind can be in this building. That is from when you enter the building in the morning until you exit the building after 3:25. Students, please remember that it is in the Student Code of Conduct and the handbook as a state law. Your very first time of having your phone taken up is the only time that I will return it to you with a detention. After the first time, your phone will only be returned to a parent and guardian. Cross-country t-shirt orders are due by this Friday. Please make sure you get those cross-country t-shirt orders to Coach O by Friday. Teachers, we are going to send you a student activity release list. You got some of those yesterday at the specified time today. Cross-country kids will be called to be released. We'll let you know. Also, there will be students out on Friday for the away football game. So please make sure you're paying attention to those student release lists that Ms. Welch is going to send you. And I think that is the only announcements for today. We will continue to be calling you to the office by grade levels for pictures. You're doing a great job and making it go quickly, so I do appreciate that. Co-pilots, I want you to remember that every pirate matters on this campus. All pirates, one code, and one course. That means I want you all showing kindness, respect, and please treat each other the way that you want to be treated. Thank you, and have a great day.
Okay, so I know some of y'all, well, the early release Friday doesn't affect this class, it's later in the afternoon, right? Okay. I do need you to know that if you are gonna be on a school activity and you know it in advance, you need to check with me beforehand to find out if there's any papers I'm gonna be passing out or anything so that you're ready to go when you come back. All right, videos are recorded. You can catch up on the work if you missed it. All right, let's go from here. All right, so whole numbers. X is a factor of 12. So let's pretend we had never seen this list. If you had a problem similar to this and you needed the factors, sometimes I've seen different teachers use this method for factoring numbers. Okay. So have you factored like this before? Kind of do a little T-chart. You always start with 1 times the number. And the key to making sure you get them all is just count up. Count every number until you either hit a number that multiplies times itself because you have a perfect square, or you hit a number you've already written down and you're done. So, does 2 go into 12? What's 2's little factor, buddy? 6. Does 3 go into 12? What's 3's little factor, buddy? 4. Next number is 4. Does 4? Oh, I've already got it on my list. My list should be complete, right? So, what do you think if I compare set F to set G?
Teachers, at this time, please release 10th grade students for pictures. 10th grade students. Thank you.
Okay, so our notation then would be if they are equal sets, I don't have to write the set or the set builder notation or the roster. I can just say capital F equals capital G. Now, something that you need to realize here, it has to be the same elements. Just because one set has 5 elements and another set has 5 elements, or one has 2 and another has 2, that doesn't make them equal sets. And there's a term for that that's coming up soon. All right? Now, next word that we will use quite a bit. Cardinal number. Have you heard that term used before?
Yeah, but I don't remember what it is.
Okay, you think you've heard that in math before? Okay, all right. You take some guesses. The number of blank contained in a blank.
Elements in a set.
Oh, it's so intuitive. The number of elements in a set. So, let's see if we can figure out some stuff about cardinal numbers. I've made up a set H, or I got a set H out of the book. I don't know where I got all this stuff. It says H is the set of all x's such that, and notice, the x is not the very next thing because the x is falling between two numbers. So it gives me a starting and a stopping number. Will I include 0 or 50 in my set? I won't, okay? So, now, if they just stop there, I would be counting from 1 through what? 49 using natural numbers. But wait, they tell me something else, that x is a multiple of 5. So, let's use the roster method for h. So what should I start with? 5. Keep them coming.
10,
Okay.
15, 40.
And y'all can just finish up. Where will I stop? 25, 30,
45.
35, 40, 45. Any questions about why I didn't use the 0 or the 50? They're not included, correct? All right. So, I need you to find the cardinal number. So what would I do? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, right? Well, there's a symbol for when you are finding a cardinal number. And it's a symbol that has a double purpose. This is the symbol for asking for the cardinal number of a set. So, if I just put H, I'm expecting you to give me some sort of a description of everything that's in H. Either a list using the roster method, or set builder notation, or I could have verbally said something really similar to what the set builder notation is. I could have said H is the set of all numbers between 0 and 50 that are multiples of 5. I could have made it more like a conversation. Conversations like that all the time. Or I could have used set builder notation. Or I could have used the roster method. Sir.
Those two little lines, those are the cardinal number times.
Where have you seen those two little lines used before?
The absolute value.
You've also seen them used as absolute value. Alright? Well, here's the deal. We're dealing with set notation. So if I showed two little lines and I put a capital number in, I put a capital letter, I didn't know what capital numbers are. I put a capital letter in it, and I've got a set with that same capital letter nearby, then I am asking you to count the elements in the set. So you will have, by the time you leave today, you will have enough information to actually start on those odd problems that you're practicing, that you can check in the back of the book. And you'll see these notations. So you need to get used to the notations and what they are asking you. So I would start on those odd numbers. You also have some even problems. So I flip back to the beginning, which was a few pages ago. You can probably get started on your CMHW, which will be turned in. Now that looks like a ton of problems, because so far your CMHWs have had like 5 problems each. But these are pretty namby-pamby. This is some pretty quick stuff. So you might have a problem somewhere out there that says, what is the cardinal number using what looks like absolute value symbols of set B, and then you just got to count set B. I have a follow-up soon. some time. Anyway, so you can start in on these odds. The purpose of doing the odds, y'all, the evens will have similar odd problems if you don't know exactly what they are asking you to do with an odd problem, with an even problem that I want on a homework, and you don't know what it's supposed to look up like, then find an odd problem in the same set of directions and look what it looks like in the back of the book, and that will help you understand what I am looking for. All right? So you should be able to start in on these guys now. So you may have problems that simply say, these two bars with a letter in between, it means give me the cardinal number. It means count the elements. So what is the cardinal number for H? 9. Pretty easy, right? Well, the next problem uses these symbols, but they actually use it as absolute value symbols. So flip the page for me. Okay. First one, pretty friendly. Second one, you don't want to sleep through the second one. I put the second one here because I believe there is one similar to this on your homework. And if you were to sleep through this problem, you are most likely to miss that, what they're asking. So, examples. Find the cardinal number of each set. All right? Well, set C is the set of all C's such that C is a continent. So it might be helpful for you to put this in the roster method to see. How many of you just know how many continents there are?
7.
Feel like there's 7? Can we name the 7 just to be sure? And I'm going to abbreviate these. Give me a continent. Asia. Okay, I'm going to abbreviate some of them. Are y'all okay with ANT for Antarctica? South America. Okay, or SAM. North America. We're getting there. Africa. Australia. So, how would I notate that I am going to give you the cardinal number of set C? That was only 6?
Yeah.
Oh gosh, me. Okay, hang on. What did I forget? You're up.
Yeah.
I don't ever notice that. Well, apparently I can't count to 7. All right, a couple people told me that's only 6. Who got me on that one?
Lane did. Lane got you.
Who?
Lane did it. Good job.
Thank you, sir.
Me too. A lot of good stuff.
I think I did. I'm not sure.
More did.
I did. Actually.
Don't trust me, people. Okay, so. You good with that? Nope. Whoa. That's not good.
That's not the, you can put a line through it.
But it would look so bad if they weren't both the same style. Okay, now, how do I write down that I am about to give you the cardinal number of set C? C with these 2 bars on each side of it. And so that is saying the cardinal number of set C is equal to 7. So when you have those symbols, you're not telling me the elements. You are telling me that you counted the elements. Could I ask for the cardinal number of the set of all x's such that x is an element of the integers?
No.
Why not?
There's too many.
Too many to count?
Yeah.
I guess
But if you had enough time, could you count them all? No.
Probably.
No, you can't. Why not?
You can't count it.
You can't count to infinity. There is no end to the list. So you cannot count how many numbers are on a list when there is no end to the list. No end. All right, so I will not ask you for the cardinal number of an infinite set. All right, now, set Y. I am wanting the cardinal number of set Y. So what do I know about set Y? Integers, and what do we think of when we think of integers? Whole numbers and their opposites. So negatives are a possibility, correct? Okay. But tell me about these Y's.
They're lowercase.
Y's are lowercase. I was thinking more in terms, tell me about the numbers that could be Y. What does this say? Is it any number, any integer between 5 and 10? What's going on right here?
The absolute value of Y.
So this time, that's absolute value symbols. That is not cardinal number symbols. What do you know about the absolute value of a number?
It makes it like opposite.
Does it make it opposite? Okay, so I got opposite, and then I got, does it make it opposite? And this is what I heard. I have no idea what words you said. So, Stephen, I think you were saying something. Don't remember. Does anybody remember what absolute value means?
Does it make it positive?
Does it make it positive?
I think what it
Or does
is.
it make it the opposite?
I thought it made it the opposite of what it was.
Okay, so quick little lesson on absolute value. Okay? Absolute value is the distance. Anybody know where I'm going with this?
From 0.
From 0. If you were to picture a number on a number line, how many spaces it is from 0? So, pick an integer. -2. Keaton, -2. How many spaces is -2 away from 0? 2. So the absolute value of -2 is 2. So if your number is negative, you do change it to the opposite sign. But somebody over here said 7 is an integer. Correct? Did I hear 7? How many spaces is 7 away from 0? 7. So what is the absolute value of 7? 7. Let's play with those two examples and see if either of them could be Y. Okay? Y is an integer, so it could be positive or negative, right? You gave me a negative, you gave me a positive, correct? But the absolute value of that number has to fall from 5 to 10. So let's test out your number. Could -2 have been a Y? Whoa. Plug -2 in here. What's the absolute value of -2? 2. Does that fall between 5 and 10? No. Ah, okay. 7. What if I plugged 7 in here?
Yes.
What's the absolute value of 7?
7.
Is that between 5 and 10?
Yes.
Okay. Oh, all right. What if I said the integer was
11th grade, please report to our teacher and pictures.
who's leaving
11th
for us right
grade.
now? Okay, who's 11? Just run on you. Grab your two. Okay. Can y'all catch up on notes, you think? Okay.
I'll give the note taking.
All right. So, did I name the number I was thinking of before that came on, or did I leave you just hanging?
Now you let it hang.
Okay, so I'm trying to make a decision. Okay, here's my decision. The number is -10. Could it be Y?
Yes.
Okay. What is the absolute value of -10? 10. It's 5 less than or equal to 10, which is less than or equal to 10?
Yeah.
Could be equal to it, right? So, what do you think should go on this list? I could use -10. Do you want to just randomly put over? You want to put some organization? Could -5 go on the list?
Yeah.
Okay. Now, what else could go on the list? Could -6 go on the list? This is not really in order, but we're kind of going backwards, right? We could put -6 on the list because it has an absolute value from 5 to 10. What else could we put on the list? -7. We've got a little bit of organization going here. It's not necessarily from lowest to highest, though, is it? Okay. What else could go on the list? -10, but now you're jumping around on me. -8, okay? How about -9? The absolute value of -9 is 9. That fits. And we already established -10. Did we talk about it? Is that it? We got the positive versions. We have the opposites of all of these because an integer and its opposite always have the same absolute value, don't they? So, what would you put on your list here? 6, 7, 8, 9, 10. He said 5 through 10. Is that good saying that? Okay. All right. Would I say the numbers between 5 and 10? Then it wouldn't include the 5 and the 10 because it does say equal. All right. Is that the complete list? Okay. People may arrange this different ways. I know in the past I've arranged it. I put -5, comma, +5. -6, comma, +6. Just kind of put them with their little opposite buddies. All right. Do you think we've covered them all? Because it's important that you have covered them all if you're going to get the cardinal number. So what is the cardinal number?
12.
Got to vote for 12. Anybody want to back that up? I've got a yes for 12. Anybody on that side of the room say it's 12? Okay. So here we have in one problem looking at these bars being the cardinal number symbol and also looking at those bars being the absolute value symbol at the same time. Is your mind blown? No, because that's like about the hardest thing from Unit 1. That's about as bad as it gets. Okay? All right. How long do I have until the 39? How long are these people going to be gone?
Not a long while. There's a lot of
A lot of juniors? So, senior class, is it fairly small?
It's like 40.
Yeah, I think
40-ish, and we'll see how long that lasts. Some people may graduate early, some people may move. Okay, somebody might move in. Is the junior class really big?
I think they have like the same amount, maybe like
Oh, really 50? It's been a while since we've graduated that many. Okay, I think that our juniors that left are pretty bright and they can figure out what's going on. Let's continue our notes, okay? All right. A minute ago, we talked about equal sets. What made sets equal?
They have the same
exact
Exact same elements, but not necessarily the same number of elements. Because I could give you set A is A, B, C, D, E, and set B is the numbers 1, 2, 3, 4, 5. Are those equal sets?
No.
Why not?
Because you get letters and numbers.
Yeah, they're not the exact same elements. But do you think they might be equivalent sets?
Yes.
Ha-ha.
They have the
So-
same cardinal.
Oh, it's like you could have typed my notes for me. Equivalent sets. Sets that have the same cardinal number. Not to be confused with equal sets. So, I have created 2 sets. I have a set Q and I have a set R. Set Q, how did I list set Q? Which one of our methods did I use here for listing? Roster method. Why is it not set builder notation?
Because it's letters.
Okay, well, you don't see the such that in there. Okay? So I would say a variable, and I would say Q is equal to set of all, maybe X is such that X is, this lends itself better to the roster method. Okay, set R.
It's also the roster method.
Roster method. I named some colors, right? Okay. What is this asking for? Wrong. Cardinal number of Q is 5. So how do you know whether it's absolute value or it's cardinal number?
Capital letter will be.
If there's a set named by the capital letter that's in there and it's nearby somewhere, it's asking the cardinal number of that set. Okay? All right? And I did use the variable y as a lowercase, so that's a little bit of a clue as well. Okay? What is the cardinal number of R? 5. Now, does that mean that Q is equal to R? They are equivalent. There's a symbol for equivalent. You want to take a guess?
Maybe like a little.
It is. I think
Curvy equal sign.
it's okay. So it's not the 2 curvy equals. It's just 1 curve. That is your symbol for equivalent sets. Have you ever seen that symbol used before in your math career?
I believe so.
Geometry.
Yeah, I was about to say, I think I saw that in geometry.
Remember what that would mean in geometry?
That the two sides of the two, like a triangle, if one was Q, one was R, and one was S, if they had that, they would clear the sides of the
No, not triangle. Okay. That's the similar symbol, and it would mean that 2 shapes were the same shape but not the same size. So one shape was a dilation of another shape. So you might have a small equilateral triangle and it got blown up to a big equilateral triangle. They were similar. All right? What is 2 little wavy lines mean? Approximately. So that's not an approximate symbol. What if you have an equal sign with a wavy on top of it? That's congruent. So that would mean 2 shapes were exactly the same. If you remove the equal part and left the wavy part, they were the same shape but not the same size. Here, this means equivalent sets. So I'm pretty sure that I'm going to put that symbol on your matching list. And then over on the other side, somewhere it will say equivalent symbol. All right. So, I have a question for you. Here's my set Q. I think the juniors have come calling in the door again. They want to get in and learn. I'm excited to be back.
I had to pick it up, so.
Wander in one at a time. Nothing disruptive about that. That's okay. No, not a problem. We want you back learning. What the hell did you wanted to be back learning? All right. True or false?
False.
Q equals R.
Oh, that's so wrong.
Whoa, but look, they have the same number of elements.
But if they're not equal,
They're equivalent. Okay. False. How can we explain this?
they use the wrong sign.
They used the wrong sign. Okay, or the wrong symbol. Why aren't they equal? The elements are different. Why does this symbol work?
The equivalent.
So they have the same amount, or using our vocabulary, they have the same cardinal number. Were you in here for cardinal number? Yeah, you were. There you go. All right. So, have you ever heard of an empty set?
No, I don't believe so.
Okay, what do you think an empty set would be? Thanks,
A
Lane.
set with nothing.
A set with nothing in it. Okay.
It looks like this.
No element.
Okay, that has no elements. All right. The empty set is also known as. Are any of y'all kind of into computer programming at all? You might have seen this particular term if you program computer stuff. All right. An empty set is also known as a null set. Have you seen the word null used ever? Okay. It's a whole bunch of nothing, doesn't it? Okay. Now, there are a few ways to notate the empty set correctly, and there are several ways to notate it incorrectly, and I always get students who do it wrong and miss a problem. So focus here. What do you think one way to show an empty set is?
Just
No,
brackets. It's like the what are they called?
Curly braces.
And then the other one's like a zero with a.
Okay, so one way is to draw braces, starting your set, closing your set, and leaving it completely empty. Pretty obvious. You would think, so you would be amazed at how many people will get these wrong. Another is to
Probably.
do our no solution symbol. So what do you think people do to get it wrong?
They put a zero in it.
Okay, they would say, put a 0 in there. That's not empty. What's the cardinal number of that set? That has one element. That is not okay. I also get students who like both symbols. This is the set of the null set symbols. This is not an empty set. That set is not empty. It has something in it. Okay.
Please release 12th grade or pictures.
Y'all should probably take your stuff with you. We're gonna.
I'll play it on.
These together, I can't even laugh. No, I didn't.
I'm not sitting like that, bro.
It's crazy.
She tells me to do that.
Dude, are we? No, the camera's muted. Yeah, no, she was cutting class. Write her up. Yeah. Awfully long time of that. The first one to get your picture. Yeah. Blackwell. She was like, she was the last one, yeah. I was up front.
All right, I'm gonna stop our video because we pretty much lost our class and we won't have them back for the next 4 minutes.
Whose phone kept going off?
That was definitely.